Greetings everyone and welcome to another edition of Mighty Lion Minute. This morning I'm at a site where I'm trying to help a client with a new hazardous materials warehouse. I wasn't aware that they were going to store hazardous materials, but now that I am, let's look into it. When a client requests the design of a warehouse for storing hazardous materials, it's crucial to understand the complexity of the project. Increased attention has been placed on warehouse design due to large-scale fire incidents, environmental concerns, and the financial risk associated with cleanups. Significant knowledge has been gained about managing such risks, especially involving the containment and drainage features needed for safe storage. In recent years, we have seen disastrous fires in facilities housing hazardous materials. This has driven improvements in warehouse design, operational and safety protocols, and regulatory oversight. Designing effective containment and drainage systems is a notable risk management design tool that intends to minimize such risks. Code developers and insurance loss control standards emphasize proper design in order to reduce loss and liability. Therefore, it is necessary to integrate containment and drainage systems that meet building safety standards as well as owner and insurance requirements. When designing a containment system for hazardous materials, several factors must be taken into account for the warehouse design. This includes floor and wall design, drainage features, and special systems like automatic stormwater valve closures. The floor design is fundamental in any hazardous materials warehouse. Before pouring concrete, a decision must be made whether to use geotechnical membranes beneath the slab or more standard products such as visqueen. In some cases, neither product will be considered. The decision depends on soil conditions, the concrete being used and formulated, chemicals being stored, various construction standards, and regulatory requirements. While such membranes may provide an additional layer of environmental protection, they also come with technical challenges and added cost. It's crucial to determine just how sealed the floor should be. Expansion and control joints in the concrete slab should be effectively sealed to prevent chemical leaks to any groundwater below. Just how liquid-tight the floor should be depends on factors such as nature of the chemicals being stored, the risk and the severity of potential spills or large-scale releases. A practical, cost-effective approach that considers all areas of design, materials, and operational safety is oftentimes the most suitable method to approach this, rather than an overly complex design. Containment and drainage in the warehouse design also involves consideration for the walls and the roof of the warehouse. Firewalls should be designed to prevent the spread of fire, especially in areas storing flammable materials. The roof should be strong enough to support necessary emergency ventilation systems while enduring the effects of fire. However, there are special cases where MFL walls, known as maximum foreseeable loss wall construction, may actually consider a roof collapse on either side of the wall, thus allowing the wall to remain freestanding. FM Global has special expertise as well as standards in this area. In terms of drainage, proper sloping and integration of systems to handle runoff by gravity from potential spills or firefighting efforts must also be accounted for. These systems must direct any hazardous materials away from sensitive areas and towards safe secondary containment zones. As to the sprinkler system, water flow needs to be considered so that the volume of hazardous materials is not necessarily the only issue. Designing a drainage system that can safely redirect fire protection water is crucial. When considering containment in a warehouse, the size of the containment area and the height of the building bunding, ramping, or curbing is essential. By way of example, a 100,000 square foot building with 1-inch containment capacity can hold around 62,000 gallons of water. If the containment height was to be increased by 3 inches, the capacity rises to 186,000 gallons. These numbers are considered important when considering water flow duration. A sprinkler system's water flow may significantly exceed the amount of hazardous materials stored. For example, in a 20,000 square foot area, if 1,800 gallons per minute was flowing over 20 minutes, that would require 2.9 inches of containment height. For a 1-hour duration, the containment height would need to be 8.7 inches. In many situations, a secondary containment system may actually be required. The systems help divert hazardous materials into further containment areas away from the main warehouse. Designing these systems requires special engineering knowledge to assure that they can handle the total volume of water and materials, especially where underground drainage pipelines are considered. In the design to transfer water or hazmat to secondary containment areas, the pipe's diameter and gradient must be considered. For example, if 2,600 GPM of water is needed to be transferred a few hundred linear feet, the pipe diameter would need to be large enough to handle the flow by gravity. The design must also consider material compatibility with the chemicals being transferred under emergency conditions, and that may also involve fire traps that would be required within the drainage system. Ensuring that all transitions are properly graded is crucial to avoiding costly alterations later. So, it is essential to work with the right experts at every stage of the project. Structural engineers, fire protection consultants, building and fire code experts, and mechanical and environmental engineers can help ensure that the facility meets all safety standards while remaining cost-effective. Further resources are available from the National Fire Protection Association, the International Code Council, the Center for Chemical Process Safety, and leading property loss control insurers. In conclusion, designing a warehouse for hazardous materials requires careful planning and expert input. Containment and drainage systems must be robust enough to handle spills, leaks, and automatic sprinkler system water flows under extreme conditions. So it's crucial to assess the site's location, soil conditions, chemical properties of the stored materials, firewall designs, fire detection and alarm systems, and anticipated water flows under worst-case conditions. So be sure to involve the right professionals, consult updated resources to ensure the design is effective, cost-efficient, and compliant with building codes and regulatory requirements. Taking time to consult, design, plan, and thoroughly review will help to prevent costly mistakes and ultimately protect your business, your employees, and the community at large. Equally important, be sure to pass on information that you've learned so that everyone improves in this unique area of warehouse design. So thanks everyone for taking a look at Mighty Line Minute today, and we'll look forward to seeing you on the next edition where we'll be getting into issues like fire protection and life safety. Take care, have a safe day, and make sure you visit mightylinetape.com.